look at 7 and 8. In 7 it says, what's the particular solution for this expression? So we have, what's the particular solution, well, I should say equation, for y prime is equal to negative 2 e to the x minus 3x squared plus x minus 4. We want the particular solution such that y evaluated at 0 it ends up being 1. So particular solution here is a technical term. This is a particular solution as opposed to a general solution. The general solution is going to be y is equal to something plus c. So when c is unknown, we call that a general solution. A particular solution is one where we have enough information to determine the value of that constant c. And usually that depends on having what's called an initial condition, which is something like this. We just need to know the value of y at a particular x value, and that's enough to get an equation that defines c. So here we want this particular solution. Again, our first step is just going to be to take the equation that defines y prime and integrate on both sides. So if I take the antiderivative on both sides, I'll get that y up to a constant is negative 2 e to the x. That's the derivative, or sorry, that's the antiderivative of negative 2 e to the x. And then minus, if I take the antiderivative of this middle term, then what I would get is I should increment the power by 1 and then divide by the new power. If I take the integral of this term, I'll get an x squared over 2 when I increment the power by 1 and divide by the new power. And then the antiderivative of a negative 4 would be a negative 4x. So we know that y is equal to this expression up to a constant. Or in other words, it's this thing plus c. Okay, and let's clean this up a tiny bit so I can cancel these 3's. We'll get that y is equal to negative 2 e to the x minus an x cubed plus an x squared over 2 minus a 4x plus c. This is our y value evaluated at x. So if you'd like to make explicit that this is a function of x, you could write y as a function of x here. But normally we just understand that y is a function of x and we suppress that notation. So now we're going to use the initial condition to determine this value of c. That's the only remaining thing to do. So I want you to think about which one of these is going to go on the left side of the equation. So the left side of the equation is y evaluated at x. Should that end up being a 0 or a 1? And if you need to think about that for a second, feel free to pause the video. But here it's important that what we're saying is that y evaluated at 0 equals 1. In other words, the y value is 1 when the x value is 0. So the left side of this equation should become a 1. That's the y value. And the x value that we're plugging in should be a 0. So this would be a negative 2 e to the 0 minus a 0 cubed plus a 0 squared over 2 minus a 4 times 0 plus c. So thankfully most of these terms are going to be zeros, but notice that the first term is not 0. The first term is a negative 2 e to the 0, which would be a negative 2 times 1. So that's a negative 2, and then minus a 0 plus a 0 minus a 0 plus a c. So far what we have is 1 is equal to negative 2 plus c. Adding 2 to both sides will give us that 3 is equal to c. But again, c is not what we were looking for in terms of the overall problem. We just needed to know the particular solution. So we're going to take this value for c and we're going to plug it into the general solution that we found a second ago. So that means that y is equal to negative 2 e to the x minus x cubed plus x squared over 2 minus 4x plus 3. And that's the particular solution. So that's what we wanted here. Problem 8 is very similar to the previous problem. So I think this would be a good one if you want to just practice or sort of solidify this stuff in your mind. It would be a good idea to just pause the video and try this on your own so that you can then fast forward the video through each of the individual steps if you get stuck. So I'll give you the opportunity to pause, but I will go ahead and solve this problem. So we want the solution to the initial value problem here. Remember that we're looking for the particular solution. We know that because we're given this initial condition, or this initial value. In other words, we won't have an answer that involves C. We'll have the ability to determine C. So our first step is just to take this expression for y prime and take an antiderivative on both sides with respect to x. So what we're going to get is y is equal to the antiderivative of 3e to the x is again going to be 3e to the x, because the 3 is along for the ride and the integral of e to the x is itself. The next term we use our power rule, so the integral of x squared is going to be an x cubed over 3, because we increment the power by 1 and then divide by the new power. And then a minus 4 will become a negative 4x whenever we integrate. But remember that this is what we know about y up to a constant. So we know that y has to equal this plus some constant. We don't know what that constant is yet. However, we can do the same thing that we did in the previous problem because we know this initial condition that the y value at x equals 0 should be 5. So we'll get the equation that 5 is equal to the right side evaluated at x equals 0, which would be this. And again, that first term is not going to be 0. It'll be 3 times 1, which is 3. The next two terms are 0, and then we'll get a plus c over here. So subtracting 3 from both sides will give you that 2 is equal to c, and then your answer is going to be the particular solution gotten by just plugging in a c value of 2. So this is what we get altogether. And that's it for this set of notes. So next week we'll start talking about some more complicated integration techniques. But for now, I just wanted to lay the foundation for integration. And the main idea is just that we're trying to undo differentiation, but because differentiation follows this nice clean set of rules, its inverse process will also follow a nice clean set of rules. And we'll talk about some of those rules in future weeks.